Okay, so here we've got a GCSE exam question in two parts. In part A, we've got to describe the single transformation that maps shape A onto shape B. And in part B, we're given a line which has been made by this function here, y equals x minus 1. And we've got a line of reflection here, which is the dotted line. And we've got to, first of all, draw this line, the reflection of this line, and then we've got to work out the equation of our reflected line. Okay, so let's have a look at the examiner's remarks. So the examiners say that in part A, a majority of students recognised that the transformation was a reflection, but only a small proportion of those also gave the equation of the mirror line. Part B wasn't well answered. Many of the reflected lines were drawn parallel to the given line, and very few students correctly identified the gradient of their line. Okay, well, let's see if we can answer first of all part A. So before we do anything, it's a good idea always to label up any shapes if they haven't already been labelled. So A, let's call this P, Q, R. Okay. And so now what we've got to do is label up the image. So the object is PQR. The image, we need to find the corresponding points. So P seems to be the easiest one. So we've got the smallest angle here, small acute angle. And so that the corresponding point must be here. And we've got a right angle at Q. So this must be Q prime. And R prime must be the one that remains, and that looks right, so this must be R prime. So how does that help with the task of describing the single transformation that translates A onto B? Well, I can tell immediately that of the four basic transformations, it's not a translation, neither can it be a rotation. And that's because if I look at this labelling, I'm going anti-clockwise around the shape with the object. So I've got P, Q, R going anti-clockwise, whereas here I've got P prime, Q prime, R prime. I'm going clockwise. So whatever the transformation has done, it certainly hasn't translated the object where I wouldn't get that reversal, nor has it rotated it, because even with a rotation, then the anti-clockwise direction of the labelling would be preserved. So good. So what I've done is I've ruled out two of the basic four basic transformations. So I'm left with enlargement or reflection. Now, I think we can see clearly that it's a reflection, but it's worth just thinking about enlargement. Could we get the same result with enlargement? Well, no, because the centre of enlargement would be here. And so Q, once it's gone through the centre of enlargement, Q prime would be where P prime is, and P would be where Q prime is, and R, well, that would enlarge to this point here. So no, it can't be an enlargement. So I can rule out enlargement as well. Of course, it could be an enlargement followed by a rotation, so that might work, but we're asked for a single transformation, so the only single transformation that's going to work here is going to be a reflection, and that makes sense. It looks like a reflection. Okay, so we're ready now to describe our transformation. So we are talking about a reflection, and what we need to know now is what is the line of reflection that reflects A to B? Well, the line of reflection is clearly in between the points here. In other words, if I draw a line from P to P prime, halfway along is going to be at this point here. Or if I choose my nearest points here, R and R prime, halfway along, bisecting the line would be this point here. So if I join, let's use a dotted line here to follow the same convention. So if I use a dotted line to join together these 2 points and join it all the way through, then it will go through x equals 5. So what we've got here then is a reflection in the line x equals 5. And that completes part A. So part B then. So in part B, we've not got a shape anymore, we've got a line. So what I'm going to do immediately again is label up the line. Well, I could use any 2 points on the line, but I might as well use the ends. So let's call this end S and this end T. So these are these points here. And S is 3 away from the line of reflection at x equals 2, so 3 away from the line of reflection, so it must be 3 the other side where we've got the position of S prime. And T, well, that's 5 away from the line of reflection, so here must be T prime. Now we can draw S and T together, T to S, to get our image of ST. Okay, so now we've drawn the line. We've drawn the line of reflection. We've drawn the reflected line, rather, the image through the line of reflection. We now need to work out the equation of the reflected line. Well, to work out an equation, then you follow this formula: y equals m, which is the gradient of the line, times the x value, plus some constant. Now the constant is going to be the y-intercept. So where it intercepts the y-axis is going to be this constant c. So we can immediately check where it intercepts the y-axis, and that's at 3, at positive 3. So we've now got y equals some gradient times the x value plus 3. Okay. Now we need to work on the gradient. Well, the gradient is rise over run. So m equals rise over run. Now you might want to write that as the change in y. So that would be y2 would be 6 minus y1, which would be negative 2. I think this gets a little bit complicated. I just prefer to count it. So we write rise over run, unless you particularly need to write y2 minus y1 over x2 minus x1. So we'll just think of it as rise over run and simply count the number of squares. So from s to t, so the rise from s to t is going to be 2 to get up to the 0 and 6 to get up to here, so it's going to be 8. And the run, well, we need to be careful here. That's going to be not going in a positive direction, but going in a negative direction. So from S to T, we have to go negatively. So the run is negative. In other words, it's going to be for 8 minus 8. So 8 divided by minus 8, it's going to give us minus 1. So finally, to complete this, we've got our gradient of negative 1. Y then must equal, so therefore y must equal negative 1, in other words just negative x plus 3. Okay.